Hello, Professor. My name is Mercy, and here is my final report presentation. My title of my report is Development of Manufacture of Electric Vehicles in Systems Engineering Division. And besides the background and the summary, it has mainly four parts. They are concept development stage, engineering development stage, post-development stage, and the systems engineering challenge. At first, let me introduce the background. Automobiles do bring convenience to people, but they also cause serious problems at the same time. The car exhaust caused the greenhouse effect, also made the ozone layer destruct and so on. With improvement of living standards, human beings are increasingly demanding the living environment, and the call for reducing the exhaust emissions of automobiles is also increasing day by day. But the number of vehicles in the world continues to increase, making humans in various countries face many challenges. The scarcity of global oil resources reserves is interrupted, and the energy shortage of several major economic powers is serious. At this stage, the development of the automobile industry, which still uses oil as its main fuel, is greatly threatened. So, under the current uncertain political and economic structure of the world, ensuring the security of oil supply has become a difficult problem that governments must solve, and reducing oil dependence has been an inevitable choice. For this, a huge number of engineers are constantly striving to find approaches to reduce fuel consumption, seek alternative fuels, and develop new vehicles that use little or no gasoline. Uh, People have realized that various types of electric vehicles and fuel cell vehicles are solutions for clean energy source. In fact, electrical cars are now known and fresh. It was popular during the 19th century, but it was very expensive as a kind of luxury of upper class. But the first production, the gasoline car, was mainstreaming because of its cost-effective price, and people start to ignore the development of electric cars. And today's electric cars integrate the latest achievements in scientific realms such as machinery, electronics, motors, intelligent control, chemical energy, computers, new materials, and engineering technology. And they are the result of a type of high-tech convergence. So there's no doubt that electric vehicles have broad prospects for development. And let's begin our concept development stage. It has three parts. The first is need analysis, and the second is concept exploration, and the third is concept definition. In the first phase, need analysis, as we all know, the main deficiencies of the current system, the fuel car, are the pollution and the depletion of resources. So R&D department need to control the cost on the electric car, including human resource and money. I don't think people may accept a related higher price than the original car, even if it is possible to save money and energy in the long run. Besides the price, users must pay attention to the life of this new system, which has many new subsystems and components. So the useful life of electric vehicles should be comparable to the level of the fuel car. And the next phase, function analysis. In this phase, the new system needs to translate operational objectives into functions and allocate functions to its subsystems. It has four fundamental functions. The first is charging system. It converts the AC power of the charging port, to DC power. And the second is high voltage power distribution unit. It is a set of components that distribute the high voltage power to the drive motor controller, the electric air conditioner compressor, and the PTC heater, high voltage power equipment. And the third is power battery. It supplies power to the drive motor, and it is the power of the entire vehicle. And the last is drive system. It consists of three parts: drive motor, reducer, and the drive motor controller. The next phase, feasibility analysis. It is the tech realization for the former analysis. At first, we could encapsulate the charging system with DC to DC, which is a technical device that converts the DC power into DC power, mainly transforming voltage and current. And second, we could use the high voltage junction box. It could introduce the high voltage power from the charger into the power battery. So it could realize the function of charging in the power battery. And third, the power battery. It could be installed on the floor of the vehicle, and it could be cooled by natural air cooling. At last, we could use the drive motor controller to link the drive motor, the start switch, the meter, the gear switch, the throttle signal, the brake signal, and so on, so that the vehicle can be carried out in an orderly manner. And here is the last phase, needs validation. Based on some related studies, this project, the new system of the electric car is obviously reasonable because it meets people's needs for the use of cars and protection of the environment and resources in the future. Moreover, by comparing the research and development costs and the annual revenue, the risks and the costs are acceptable. Tesla is a good case in point. And here are the research costs and annual revenue of Tesla from 2010 to 2018. And it is clear to show that this system is making profit, which increases year by year. And here comes the second part of the concept development stage. It is called the concept exploration, and it will also use 4 system engineering methods to complete this part. And the first is operational requirements analysis. The second is performance requirement formulation. The third is implementation of concept exploration. And last is performance requirement validation. In the first phase, operational requirements analysis. Since in the new system, electric cars use electric energy to drive, so its biggest operational requirement is to solve its charging problem. If the user can't charge the cars in time and conveniently, the system can't be operated, and it will now attract more consumers and users' attention. And in the next phase, the performance requirement formulation. In order to translate this requirement into the whole system, electric car related companies need to popularize the charging paths as subsystems in every corner of every cities, every countries, so that when the users and customers electric vehicles need to be recharged, they can find the nearest charging paths to solve the urgent need. And in my opinion, it could be completed by 2 main parts. The first is the hardware, and the second is the software. The hardware is for the charging paths, and the software is for some mobile application on our cell phone to give some information for users. In the implementation of concept exploration, in this stage, the main two aspects need to be considered. The technology company must first implement the function of the charging station and then let the user know and choose where to charge. An AC charging panel could provide AC voltage to electric. The corresponding company can develop a mobile app to provide users with the location and working status of the charging panel. For example, the charging panel must give the electric cars a good charging efficiency to save some times, and the mobile app will provide the users information including the GPS and whether the charging panel is in good condition and so on. In the next phase, the performance requirement validation. Because this system is both need and technology driven. It needs customers and system developers work to validate its performance. In detail, the company could arrange some customers to test these subsystems and the developers could operate and maintain, such like finding if there are some errors and bugs in the mobile applications and whether the charger pack could be regularly used in their life cycle. The third part of the concept development stage is the concept definition. It will explain what is an electric vehicle and what can electric car do. An electric vehicle is a brand new and alternative energy source automobile that uses electric motors and motor controllers for propulsion, instead of common propulsion ways such as the internal combustion engine. Electricity could be used as a fuel to power battery electric cars. It stores electricity in an energy storage device as a battery system. The electricity powers the wheels of cars by an electric motor. Electric vehicles have limited energy storage capacity, which should be replenished while charging into an electrical source. And now let's begin the next stage, engineering development stage. It has mainly three parts. The first is advanced development, and the second part is engineering design, and the third part is about integration and evaluation. So let me introduce these three parts one by one. And in advanced development, we need a requirement analysis. And the first in it is function and performance analysis. The biggest controversy in the performance of electric cars and ordinary cars come from battery life. The current average battery life of electric cars is around 150 to 300 kilometers, and it may have degradation after using for a long time. Compared with ordinary cars, the mileage is 500 kilometers. The gap is not the same from a single battery life. According to the average annual mileage of 20,000 kilometers of passenger cars, the average daily mileage is generally less than 100 kilometers. The electric cars can basically meet 85% of user requirements. And the second thing in requirement analysis is durability. The difference in durability between electric cars and automobiles lies mainly in the battery cycle life. It is calculated by a typical ternary lithium battery pack with a capacity of 30 kilowatts-hour. The basic energy consumption per 100 kilometers is 20 kilowatts-hour. and the lithium battery has a reasonable life charge and discharge of 1,000 times. The basic equipment mileage is 150,000 kilometers. The basic equivalent use period is 7 to 8 years, compared with the current scrapping standards of normal cars. There is still a big gap. So in other words, the depreciation rate of electric cars is higher. And the third thing in requirement analysis is the ease of use. It's the shortcoming of electric cars, mainly reflected in the lack of supporting charging facilities and charging time, which determine the characteristics of its inability to use high mileage for a long time. The current charging time is about 9 hours. Even if you use fast charging technology, it takes at least 1 hour to reach the power for short distance use, which causes great inconvenience to users. The next phase in advanced development is functional analysis and design. First, we need to understand what the definition about a pure electric drive is. The force driving the car must be mechanical. The mechanical force drives the car currently comes from the mechanical force of the engine output and the mechanical force of the motor output. Other forms of mechanical force drive the car forward is estimated that there is no possibility of becoming a commodity. The basic meaning of the word pure is that the mechanical force drive the car is a single mechanical force derived from the output of the motor. Even if there is an internal combustion engine on the car, it's not used as an engine. Different energy replenishing devices have different hardware and mechanisms. For example, the power battery can be charged by an inductive and contact type charger, or the replaced power battery can be centrally charged by replacing the power battery. And the next phase is prototype development. Here is the prototype development and its testing period of the BMW hydrogen fuel cell vehicle to illustrate the process at this stage. After BMW directors approve a new generation of hydrogen fuel cells, a new generation of hydrogen fuel cell vehicles has emerged. Engineers can turn their high-tech i8 plug-in hybrid into a more technologically advanced hydrogen-fueled electric car. The car is equipped with a long, cylindrical hydrogen-fueled tank with an internal pressure of up to 700 bar. Although the car has never been ready for mass production, it has provided a springboard for the development of two other prototypes based on the 5 Series GT. The i8-based hydrogen fuel cell prototype can store 4 kilograms of liquid hydrogen with a driving range of more than 350 kilometers. The earliest 5 Series GT prototype increased hydrogen storage to 4.5 kilograms, then increasing the driving range. As early as 2006, BMW used low-temperature hydrogen fuel storage tanks on its Hydrogen 7 Series and second 5 Series GT models. This storage tank looks like the conventional general storage tank from the outside, but in fact it can store 7 kilograms of liquid hydrogen at a pressure of only 350 bar, which can increase the vehicle's driving range to 700 kilometers. And next we come into the development test. In view of the fact that a hydrogen fuel cell vehicle is essentially a battery electric vehicle, it only uses hydrogen fuel as a larger power battery for an on-demand power supply, and its driving is similar to a battery electric car. Although the structure is similar, the core changing will have a huge impact, so development testing is required. Models such as the IA hydrogen fuel cell prototype and the fuel cell 5 series GT prototype are all research cars. These models are mainly used for the test and verification after development. The purpose of this work is not only about driving pleasure, but about how to respond to innovation creation and customer interest at an appropriate price level in the future. Inside the compartment of the fuel cell 5 series GT prototype, press the start button to start the car. Pull the drive to the stand BMW automatic gear and then drive a two-pedal car. Compared with the standard version of this car, the fuel cell 5 Series GT prototype is obviously heavier, but its driving performance is still smooth and light. Compared to Audi A7 is more powerful than this car. BMW claims that their hydrogen fuel cell cars have an acceleration time of 8.4 seconds for 100 kilometers. If on a very hot day there are three people sitting in the car and the car has been driving for several hours, the speed of 100 kilometers per hour is about 10 seconds. Then there is the second part of the engineering development stage. It is the engineering design. And then first we need to go through the reliability. What's the reliability of the car? In general, people need to know whether their car is easy to break. For traditional cars, there are many parts of the whole vehicle. The mechanical complexity is high, and the factors affecting reliability are various. So, so this is a test of the design and development of manufacturing level of the OEM. But the situation changed very much when switching to a pure electric car. And then we need to analyze the structure of the maintainability. The electric vehicle maintenance system divides the maintenance of the vehicle into daily maintenance, first level maintenance, and second level maintenance. In addition to the seasonal maintenance, the central content of daily maintenance is cleaning, replenishment, and safety inspection. The purpose of routine maintenance of electric vehicles is to identify hidden dangers and ensure the electric cars have the ability to drive safely and cleanly. The first level maintenance of electric cars is carried out by professional maintenance workers. The central content of the second level is mainly for inspection and adjustment, and the tiers are dismantled for tier replacement. And the last seasonal maintenance refers to electric car entering in the summer and winter, the maintenance of the car before the season change, so that the electric car is well adapted to changing operation conditions. And then we need to go through the producibility. New energy car manufacturing is more prosperous than ever before, and the transformative effects of new electric cars on the automobile industry are increasingly apparent. But its level of production informatization is now high, and the management level of the production process is still relatively backward. So we need to strengthen the on-site management of each production section to improve the production quality and performance of new energy vehicles. We need to use MES technology into the management of production process to solve problems in their actual production. It will greatly improve the production level. And next step, we are coming to the third part of the engineering development stage. It is integration and evaluation. According to the operational requirement above, the main problem of electric cars is still the performance of the battery and the charging problem. So in this stage, the performance test is required. It is uh, including two levels. The first is the vehicle level test, and the second is the component level test. In the vehicle level, first it has power test. It is to assess the highest speed, the lowest stable speed, the internal resistance, the starting acceleration, and the overspeed acceleration. And then is the economy test. It includes multi-case energy consumption, high and low temperature energy consumption, and the normal electrical energy consumption. What is more is the safety test. It is to evaluate isolation resistance, weighting, and immersion of the vehicle. Also, the high pressure resistance test. At last, it is the battery compatibility test. It includes electromagnetic disturbance of the vehicle, electromagnetic immunity, electromagnetic field radiation, high current charging immunity test, and human body electromagnetic protection. The next level is component level in performance tests. Component level testing of electric cars including power battery aspects and drive motors. The main aspects of the power battery are tests including environmental adaptability, charge and discharge rate, mechanical safety, and electrical performance. In addition, the tests for the drive motor mainly includes performance tests such as vibration speed and torque. And then please let me introduce the third part of this report, the post-development stage. It has two parts. The first is production, and the second is operation and support. The Tesla road rescue team has instant road rescue convenience services. A malfunction that causes the vehicle to be unable to drive, the team is responsible for transporting the vehicle to the nearest service center. Damage to the hub or tail causes a puncture or unsafe driving, the team can provide a trailer service within 80 kilometers. The situation in which the vehicle can now be unlocked properly due to a vehicle remotely key or application failure, the team can try to help you unlock it remotely. And Tesla also has Air software updates to add new features. The user can click on the Tesla T letter on the car touchscreen to get the latest release notes for the current vehicle. A new window will appear. Click on Publish Description in the lower right corner of the page. Software updates can introduce new features and improve vehicle performance so that the safety and functionality of the vehicle can be improved within the times. If the vehicle has a software update that has not yet been downloaded, Tesla will alert users via the touch screen and the Tesla mobile app. These updates are automatically received when the vehicle is connected to Wi-Fi. When you receive an update reminder, you can choose to install it now or install it later. The time required to install a software update will vary, and the reminder will show a significant amount of time. The vehicle will not be able to drive during the software update. And the last part, I will list some challenges for the electric cars. And it has four basic challenges. The first is battery life. The second is charging efficiency. The third is electric vehicle charging source. And the last is raw materials for battery manufacturing. For the first challenge, battery life. Because electric vehicles are subject to power battery capacity, most electric vehicles could not reach long-distance driving conditions. Although there have been many electric cars that claim to have a large cruising range of more than 300 kilometers, the cruising range of electric vehicles is obviously dwarfed for pure electric vehicles that often travel between the two places. The reason for the short cruising range of electric vehicles is that there are technical problems in addition to the manufacturing costs of electric cars. With the advancement of science and technology, developers need to develop electric vehicles with battery life of 2 to 3 times the endurance. And for the second challenge, charging efficiency. Today's electric vehicles are not widely used because it consumes too much time to charge it. The original purchase of the car as a means of transportation is to improve our living efficiency, make it easier for us to go out. However, if an emergency situation which requires us immediately happens, such as going to the hospital, station, going to a meeting, the advantage of the fuel car will come out. Consumers expect that with the development of tech, the battery's power density will gradually increase, and the charging time will be short, and the endurance must be strong. And the next challenge, the electric vehicle charging source. If the electricity comes from traditional sources such as coal, oil, or natural gas, then electric vehicles will not play a role in climate change. What makes people feel a bit strange is that the benefits of electric cars depend on their charging power because it all depends on the local energy production portfolio. A change in local energy production means that electric vehicles are sometimes more polluted than ordinary cars. If people live in places that rely on coal to generate electricity, the improvement of the environment electric vehicles may not be much better than that of fuel vehicles. For example, in India, electric cars are almost the same as traditional cars, where power generation is still dominated by fossil fuels. And the last challenge, raw materials for battery manufacturing. Even if the global energy supply is converted to renewable energy, it will have to extract more cobalt, lithium, and other raw materials to make batteries. And it needs to be carried out in a sustainable and responsible manner. For example, more than 60% of the world's cobalt, the key source of lithium-ion batteries, comes from the Democratic Republic of the Congo. Researchers are working on new types of batteries that require less controversial raw materials, which will help the countries that have proposed a fuel vehicle ban to fulfill their promise of renewable energy in an ideal situation.
The last part I want to summarize this report. This report has carried out many details and contains the manufacturing process of the electric vehicle industry from the perspective of systems and engineering. First, we must have a clear definition of the concept of this system, such as what is the electric car to be developed in the new era, what are the benefits of using new energy. And the next step is to enter the engineering development stage. We must know which technologies are mature and proven because in advanced development, engineers must understand the potential impact of technology applications. Then this process illustrates some development prototypes and test data for electric cars. Next, performance testing of the entire electric car system is required to demonstrate the integration of all subsystems and components, including safety, power, and economy testing. In addition, there are post-development stages, including production and operation and support, where Tesla examples are used to illustrate problems in electric cars production and after-sales support and services. Finally, this post mentions unavoidable challenges in electric car systems, including battery performance, charging facility issues, and battery manufacturing technologies. Finally, I want to tell you what I learned in this class. I think what benefited me the most was that I got a detailed analysis of the system engineering architecture. For example, I have only listed a few related questions before, but they are not representative. But this class allows me to expand from a familiar node to see a more comprehensive knowledge system. And this system can be fully adapted to many industries. So I'm very grateful for the opportunity to choose this course and finish all the courses tests. Thanks for the help and guidance of my classmates and teacher in this process. Thank you, Professor. That's my final presentation.